something outran the stars over Mars. October 2025. As Perseverance's night sky cameras stared into the thin Martian darkness, a single streak sliced across the frame, razor sharp, traveling 60 kilometers per second. Within hours, that number echoed across astronomy forums, the exact speed predicted for Interstellar Visitor 3, I-Atlas, during its first historic flyby of Mars. Then, the feed went dark. Mars orbiters, silent, raw images, missing. And in the vacuum of official data, a storm of speculation ignited. Did Mars just record the fastest object ever seen from another world? Or something no comet should ever do? Tonight, we're standing at the edge of a mystery unfolding in real time, a story written in missing frames, green flashes, and the uneasy question haunting every scientist watching the skies over Mars. What exactly flew by that night? The first alerts didn't come from NASA or ESA. They came from a quiet corner of the internet. Amateur astronomers digging through Perseverance's public raw image archive. Among them was Stephen Burns, a software engineer and longtime deep sky imager who stitched together a 9-minute sequence from the rover's night cameras. What he found stopped him cold, a razor-thin streak moving too fast, too straight, and too bright to be a meteor or cosmic ray hit. 60 kilometers per second, consistent across every frame. That speed alone made it an outlier. No known satellite around Mars moves that fast. Even high-velocity meteors burn out before reaching such steadiness. Burns checked and rechecked, aligning the streak against fixed background stars, calibrating plate scale with US catalog data, verifying timestamps. The numbers held. When the data was released, 1,000 independent analysts jumped on it. Some confirmed the finding, others called it noise, a compression artifact, or a processing illusion. But the timing was uncanny. The streak appeared exactly when 3I Atlas, only the third confirmed interstellar visitor after Oumuamua and Borisov, was calculated to pass within 75 lunar distances of Mars. It raised a simple but unsettling question. Why did the object behave nothing like a comet? No diffuse tail, no predictable outgassing curve, no deviation under solar pressure. Instead, it moved with a precision that looked engineered, straight, steady, indifferent to sunlight. Burns urged caution, yet the implication was clear. If the streak was real, Mars had just become the first outpost to witness an interstellar flyby firsthand. And what it saw didn't fit any model. Within days, data channels lit up with contradictions. The Perseverance frames showed the 60 kilometer per second streak, but when observers turned to the Mars orbiters, silence. High rise on Mars Reconnaissance Orbiter, Cassie's on the Trace Gas Orbiter, and HRSC aboard Mars Express had all been scheduled to capture the flyby. Yet no raw images appeared. Normally, even uncalibrated previews reach the planetary data system within a week. This time, nothing. Engineers cited calibration hold, but for a global community accustomed to transparency, that explanation only sharpened curiosity. Then came the green flash. A single frame sequence posted by an independent group showed a faint emerald bloom at EUR/03 UTC on October 2nd, the same moment Burns's stacked images recorded the streak. In comet physics, a green glow means one thing: dicarbon emission, the chemical hallmark of sublimating carbon chains. But preliminary spectra from the Mars Express team told a different story. No dicarbon bands at all. The usual swan lines near 516 and 563 nanometers were missing. Instead, nickel lines spiked far above iron, and carbon dioxide dominated where water vapor should have led. Scientists split into camps. The naturalists argued that the comet was simply unusual, its chemistry depleted, its jets unusually CO2-rich, maybe fractured by an earlier pass through the solar system. Others, more cautious, said the pattern was too clean, too stable, to be explained by random fragmentation. In simulations, only a dense, heavy nucleus, 10 billion tons or more, could hold that trajectory without measurable non-gravitational drift. Meanwhile, dynamic models revealed another puzzle. The jet didn't trail away from the sun. It pointed toward it. An anti-tail. That geometry is known but rare, demanding extremely precise particle sizes and emission timing. For 3I Atlas, it appeared almost engineered, a narrow sunward plume, fading sharply instead of fanning out. Every anomaly deepened the rift between caution and wonder. If these measurements were right, this visitor was rewriting the Comet rulebook: green without the molecule that makes it green, heavy without slowing down, and active without deviation. Even among hardened professionals, the phrase began circulating quietly: non-natural behavior. No one said artificial, not yet. But the words hovered, waiting for data strong enough to make them acceptable. October 4th, 2025. Mars had become the only place in the solar system capable of seeing 3I Atlas clearly. Earth's telescopes were blinded by the sun. Even the James Webb Space Telescope was out of position, shielded for safety. That left 3 orbiters, HiRISE, CASSIS, and HRSC, each armed with different optics, pointing their cameras into the deep Martian night. Every exposure was a bet against geometry, a race against time. HiRISE, built to map boulders on Martian slopes, was never designed to chase a target racing across the sky at 60 kilometers per second. Its narrow field of view meant engineers had to offset the aim by degrees, predicting where the object would be minutes ahead. CASSIS, tuned for color and jet analysis, ran 4-band exposures, hoping to catch spectral hints: green, red, ultraviolet, of whatever chemistry powered the visitor's coma. HRSC, with its broad swath imaging, scanned the sky for larger structures, fragments, debris fields, or unusual plumes. The coordination between agencies was intense. Every orbit had to be recalculated daily, every slew command tested. A single wrong vector, and the object would vanish off the sensor forever. The data pipeline was primed for priority downlink, but when the moment came, nothing appeared in the public feed. The usual quick-look images, gone. The preliminary FITS files, missing. Instead, terse updates appeared on internal dashboards. Under calibration, awaiting verification. Inside JPL, the imaging teams were running emergency checks. The problem wasn't bandwidth. It was fear. Fear of releasing frames riddled with cosmic ray noise or hot pixels that might be mistaken for fragments. For fast-moving targets, standard cosmic ray filters fail. The algorithms can't tell a genuine streak from an artifact. Releasing those frames too early could ignite a frenzy. Wait too long, and the silence would feed conspiracy. The tension was palpable. Tonight's event wasn't just about what Mars saw. It was about who controlled the narrative of discovery. For the first time, the only clear window on an interstellar object didn't belong to Earth. It belonged to machines orbiting another world, transmitting to teams who now had to decide, what do you show the public when every pixel could change the story of how we see the universe? By the 5th of October, the science channels were flooded with one question: what exactly is 3I Atlas? With data still under lock at JPL and ESA, researchers built 3 competing models, each plausible, each unsettling in its own way. The safe scenario was the most conservative. It treated the object as a comet, just one unlike any seen before. Its nickel-heavy spectrum, CO2-driven jets, and missing water lines could, in theory, be explained by an origin in a cold, carbon-rich region of another star system. There, water ice would have sublimated away long before entering ours, leaving behind denser volatile compounds. The anti-tail, in this version, was a geometric illusion, fine dust particles scattering sunlight forward, not backward. It was weird, yes, but natural weirdness is the universe's trademark. The dangerous scenario painted a different picture. In this model, 3I Atlas wasn't entirely stable. The green flash seen at 0203 UTC could have been an outburst, an explosive venting of gas or fragmentation event. If true, the lack of follow-up data could signal a cloud of debris spreading silently through Mars's orbital corridor. Even a small fragment traveling 60 kilometers per second could devastate a spacecraft on impact. Engineers began quietly adjusting orbital safety margins. The Mars Reconnaissance Orbiter performed a minor roll maneuver on October 6th, officially for calibration. Unofficially, it looked a lot like a sidestep. And then came the extreme scenario, the one nobody wanted to voice aloud. Suppose the object's behavior wasn't random. The steady trajectory, the anti-tail pointing sunward, the lack of rotational flicker, all implied control or pattern. Some theorists proposed an engineered body, a probe or the shard of technology drifting through interstellar space, powered not by jets but by something we didn't yet understand. The coincidence with the 1977 WOW radio signal location only fueled the whispers, statistically small, less than 1%, but hauntingly specific. To be clear, no credible scientist declared the 3I Atlas artificial, but the math was damningly tidy. No measurable non-gravitational acceleration, no chaotic spin, a mass comparable to a large asteroid, yet showing transient emission lines. If it was a comet, it was the most disciplined one ever discovered. If it wasn't, then the boundary between natural and engineered objects in the cosmos just blurred. Each model carried its own risk. The safe meant the story would fade into routine. The dangerous meant hidden debris waiting in Martian space. The extreme meant rewriting the definition of interstellar visitors. And, as of tonight, every scenario remained open, hanging on images still unseen and data still encrypted. If the anomalies of 3I Atlas hold up, the consequences stretch far beyond Mars. For planetary science, it would mean rewriting every model of comet chemistry and interstellar formation. A nickel-dominated, carbon dioxide-rich nucleus challenges the idea that all comets are built from the same frozen recipe of water, carbon, and silicates. It would imply new astrophysical factories, places where worlds form colder, darker, and older than we ever imagined. But if the object proves non-natural, even in part, the shockwave will reach deeper. The next generation of missions, those targeting interstellar probes like the Interceptor or the Comet Astrobiology Explorer, would have to carry not only instruments but protocols for encountering something built. For decades, SETI scientists have debated how humanity should respond to an engineered artifact. Suddenly, that question wouldn't be theoretical anymore. Then there's the matter of ownership. Who controls the data? NASA, ESA, or the global public who funded them? If one agency classifies its imagery, does that secrecy protect science or bury it? For the first time, Mars became a sovereign vantage point, and whoever holds that vantage controls the narrative of discovery. In an age of instant transparency, silence breeds its own conspiracy. Philosophers of science have already begun to weigh in. They argue that what we choose not to release defines our civilization as much as what we share. When evidence crosses the line from curiosity to existential question, the ethics of disclosure become as critical as the data itself. Are we ready for that? Because if 3I Atlas is simply a rock, our models adapt, our telescopes recalibrate, and the mystery fades. But if it's not, if some fragment of technology drifted across the solar system and brushed the cameras on Mars, then this is the threshold moment. The first time another world became the witness to something not born of its own sky. The story of discovery would no longer belong only to Earth. It would belong to the universe itself. While theories multiplied, people worked through the night. At the Jet Propulsion Laboratory, engineers leaned over flickering monitors, frame by frame, comparing streaks of static against predicted ephemerides. Every pixel mattered. They knew that releasing a single misaligned image could trigger chaos online. "Slow is honest," one technician wrote on the whiteboard, a mantra for a team suddenly responsible for guarding history. Half a planet away, amateur astronomers stayed awake in basements and backyards. Stephen Burns, the man who started it all, live-streamed his process, inviting anyone to verify his math. Viewers watched him rebuild his pipeline in real time, recalibrating timestamps, subtracting bias noise, cross-matching star catalogs. Thousands followed, learning how raw science looks before the headlines polish it. For many, this was the first time they'd seen discovery not as a press release, but as sleepless humans fighting fatigue and doubt. Forums became command centers, coders traded stacking scripts, spectroscopists shared color corrections. A group of students in Arizona even built a public dashboard, tracking when NASA's servers updated new Perseverance frames, celebrating every timestamp, as if it were a lunar landing. Inside the orbiting spacecraft, autonomous systems kept working silently. Cameras rotated, gyroscopes whirred. No one on Earth could see what they saw, not yet. The data flowed through deep space relays, waiting to be unpacked. In those long hours, science felt almost spiritual. Thousands of minds connected by the same anticipation, staring into the same digital void, searching for a truth that might upend everything. They weren't chasing aliens. They were chasing certainty, the rarest commodity in modern science. Whether the streak over Mars was dust, ice, or design, these people reminded the world that knowledge is built one pixel at a time by humans who refuse to look away. As the sun rose over the red horizon of Mars, no new images arrived, just the steady hum of expectation. The world waited, scrolling, refreshing, hoping that somewhere in that unseen data lay a simple answer. But the universe rarely gives us simple answers. If 3I Atlas turns out to be only rock and gas, the lesson will still be profound. That even ordinary matter, when seen under new light, can shake our understanding of how worlds form. If it's something else, something engineered, something deliberate, then humanity will face a truth older than history itself. We were never alone in the act of discovery. The real revelation isn't in what the cameras captured, but in what the silence revealed about us, our impatience, our curiosity, our hunger to know. In every lab and living room, people felt the same pulse of wonder, not fear, wonder. Because science at its best is not about certainty. It's about the courage to stand in the unknown and keep looking. Tomorrow, the calibration team will finish their review. The frames will drop, and the debate will begin again. Maybe we'll see a smudge, a flash, a pattern that changes everything, or nothing at all. But for now, on this quiet October morning, one fact remains. Something crossed the Martian starscape at 60 kilometers per second, and for a brief electric moment, all of humanity looked up together. The mystery endures, and that's how discovery begins.